around my list. I don't think you met Justin, so maybe I'll just go through the list for introductions, and I will spare Christopher because I think he just joined. So I'll just start for Elisha, if he can maybe start with his introduction, please. Elisha.
Okay, morning. My name is Elisha Mahadamombe. I'm working in the Pupusa area, that's the Buzi, Pungwe, and Save river basins. These are rivers that are shared between Zimbabwe and Mozambique. And at the moment, we are working on elaborating the water sharing agreements. And in those water sharing agreements, we also have a component of floods and drought early warning systems, as well as climate change, etc. So in short, that's what I can say.
Okay, fine. So I'm just going down my list. I have Tawanda. There's a few more people joining, so I'll have to adjust a bit to that. But Tawanda, just introduce yourself.
Hi, good morning. My name is Tawanda Gijima, working with Dr. Kun at the region of Southern Africa, mainly focusing on the water programs and also assisting in the mainly the biosphere reserve programs and also assisting with the youth programs. Thank you.
All right, then I have Justin, you're following.
Yeah, hi everyone. My name is Justin Sheffield. I'm a professor at the University of Southampton, and my background is in hydrology and remote sensing. And I'm also a co-founder of the Princeton Climate Institute, which has co-developed this system that I'm going to show with Princeton and University of Southampton.
All right, Lena, please.
Yeah, good morning, everyone. I'm Lena. I work for the German Red Cross as Regional Forecast-Based Financing Delegate, and I'm supporting Mozambique Red Cross in close collaboration with INAM, the National Hydromet, and the Disaster Management Authority in setting up anticipatory humanitarian action with the focus on floods in the four main river basins, cyclones, and now currently working on a protocol for drought risk. Over to you.
All right. Philip, you're next.
Good morning, everybody. Yeah, my name is Philip Hull. I am with the company JG Africa. My interest in flood early warning systems is such that we are involved in other projects in the region, and so it's just interesting to keep in contact with Dr. Kun and see what's happening with this project. Thanks.
I may just also make the link with the USAID program, Resilience Water Program, that you also have been connected with, right?
Yes, that's specifically for the Okavango River Basin, where we're developing a flood early warning system for that basin as well. Thanks.
Okay, thanks. I have Hilario Pereira.
Yes, morning, everyone. My name is Hilario Pereira, head of International River Department, National Directorate of Water Resource Management, Mozambique. Thank you.
It's good to have also the water department on board. Thank you. I have a person, I don't have the first name, Nantumbo.
Hi, everyone. This is Bernardine Nyantum. I'm a climate researcher at the National Institute of Meteorology in Mozambique.
Excellent. Thanks for that. And the final one is Christopher, I have on my list.
Hi there, I'm Chris Gegenheimer. I'm a digital development specialist working with USAID Resilient Waters Program and Bukanau.
All right, thank you for that. I think we have indeed more or less the list of people we want to have here. So thanks for that. And I think we can then give the floor to Justin for his introductory presentation. Justin, your floor is yours.
Right, thanks, Kuhn. So can you see this presentation?
Very well from my end, thank you.
Okay. All right, thanks everyone for coming. As Kuhn said, this is essentially an update on the work that we were doing previously with the Mozambique flood and drought monitor. So that was introduced last year to many of you. And we've done quite a bit of work to go to a next version of that. And I'll give an overview in this presentation for about 10 or 15 minutes. And then I'll switch to going to the actual online system just to give you a quick tour. And hopefully there'll be time for kind of questions and feedback at towards the end of that. So in terms of what I'll talk about in this presentation, firstly, how to access it. So it's a open source online system. So, you know, anyone can go take a look at this. I mean, that was part of the criteria for putting this together. I'll talk about the overall approach, how we put the system together, the models, the data, the methods, and so on, and then talk about some of the data products that come out of this that's really focused on floods and droughts, and a little bit about potential applications, thinking about early warning systems, but also a bit about planning to do with water resources and drought over longer timescales. And as I said, we'll have a quick tour and then hopefully time for questions and feedback at the end. So this is what the system looks like online. So you can see it's there's a map interface and there's lots of kind of interactive aspects there. So what we tried to do over the last year is actually try to make it much more interactive for the user, adding in new features and new data products and ways of visualizing the information in a kind of a intuitive way. So as I said, we'll go through the interface in a little while. So you can get to the system through this web address here, stream.princeton.edu /moz_app. There is no registration or login required. So the system, as I said, is open access. And if you're interested, technically speaking, then the interface itself, so not the data and the models, but the interface that allows access to the system and the data is written in the R programming language and uses the R Shiny interface builder, which is essentially a library for the R programming language that allows these types of interactive interfaces to be built reasonably easily. So if you're interested in the technical side of things, I can always let you know some more details offline as well. So just a few caveats and potential bugs, I hope not, but potentially. So this is a new version of the system, and especially the web interface. So when you log on to the system, when you open the system, it does take a few seconds to initialize. That's part of the intricacies of the R Shiny library. The time is really to render the maps, but once it's loaded, it should be very responsive. Now, there may be a few bugs and some things that don't work yet. We've been through most of the functionality. And as Kuhn said, we have other systems going as well. So we have a good sense of what still needs improving. But if you do find things, then let us know. We do value that feedback. But as I said, it should be pretty responsive and you know, everything should be working. But let us know if you find something. So here's the overall approach in terms of the models and the data and how we actually run it. So the system is updated about every day, and it's about 2 days behind real time. So you'll see some, when I start showing the system, you'll see information from the 28th of March. So it's a couple of days behind real time. We're actually trying to get it closer and closer to real time. And obviously there are limitations in terms of the data streams, especially coming from satellite data and model data. But I think we can get to about 1 day behind real time, and potentially for some aspects, a matter of maybe 12 hours behind real time. But that's something we're working on. So the system gets updated every day. We have a historic data set that forms the kind of climatology to the system, and that's used for you know, evaluating current conditions and the forecasts against to give us a sense of how you know, big the flood is or the drought is and so on. So we, in terms of the real-time data, we use a bunch of different satellite products. So MSWEP is our key precipitation product that you may have heard of. And this combines satellite information with reanalysis model data and on-the-ground station data where available. And there's a version called MSMet, which gives us the temperature, the humidity, and the surface radiation as well. That gets pushed through a hydrological model. We're using the HBV model, and I'll explain a little bit about that later. And that produces hydrological information, so soil moisture, stream flow, evapotranspiration, and so on. That information provides initial conditions for the forecast. So we do forecasts on 2 timescales. So the first one is short-term forecasts that are updated every day in the same way as the real-time monitoring or the near real-time monitoring. And that goes out to 7 days. That's mainly focused on flooding, but you can think about other kinds of short-term extreme events as well, such as heat waves, or in some places where we have frost. Again, we take weather data from that forecast and push it through a hydrological model to give us those forecasts of the hydrological variables, as well as different indices for stream flow and soil moisture out to 7 days. Those forecasts are driven by a global weather model called GFS, which comes out of the US, and we use an ensemble version of that, which I'll explain a little bit more about later. The other timescale that we look at is seasonal. So these seasonal forecasts are updated every month, so around about the 1st of the month. And this takes climate data, so precipitation, temperature again, from global seasonal climate models, and we use a range of models from the EU Copernicus Climate Change Service. So they're running about 5 or 6 different global climate models operationally. So we take that data, we downscale it, we bias correct it, and again, we push it through our hydrological model to give us forecasts of those variables, those hydrological variables, and other indices derived from those out to 6 months into the future. Again, it's an ensemble of forecasts to capture the uncertainties. So the key part of the system is the hydrological modeling. We use a model called HBV. It's a relatively simple model, and that has a number of benefits in that it can be calibrated quite rapidly. So if we have available observational data such as stream flow, or we can use satellite data as well, we can calibrate the model and update it quite quickly. It can also be applied at high resolution. So the system is currently run at 5-kilometer resolution over Mozambique, and this is a subset of a larger global system. So this quite simple model allows us to actually run the model very rapidly. And it also allows us to run many ensemble forecasts as well to capture those uncertainties. So the hydrological model HBV predicts runoff, as well as the other hydrological variables such as evapotranspiration and soil moisture. That runoff is fed into a stream flow model called RAPID, and that works on a vector basis, river network basis, and you can see that over on the right for Mozambique. You can see the detail of the river network that we're predicting at. So we're predicting at each of those little river reaches, and I forget how many there are over the whole of Mozambique, but it's several thousand. So we actually get to quite detailed high resolution with this combination of models here, and the somewhat simple basis of those allows us to do this rapidly and for multiple forecasts, ensemble forecasts as well. In terms of the meteorological data, as I said, we have our MSWEP data set. That is historical. It goes back to 1979 up until near real time. So that forms the basis for everything, being the most important kind of driver of the system. And that is used to bias correct the forecast at the 2 timescales as well, the short-term GFS forecast and also the seasonal forecast from the Copernicus Climate Change Service. This MSWEP data set, as I said, it's a combination, it's a merging of different sources, satellite model and gauge observation. And we've done quite a lot of work in trying to evaluate that product globally and also regionally. And we find that it outperforms just about every other kind of similar satellite-based data set. And we've done that in many ways, looking at independent gauge observations, but also pushing that data through a hydrological model and evaluating against observed streamflow data. So we're pretty confident that it's a good data set. And of course, it can be improved if there are available observational data that we can assimilate into that data set. In terms of the seasonal forecast, I just want to mention for the operational system that we see with the web interface, we're just using one of those seasonal climate models, which is the ECMWF4 seasonal forecast model. And we've done quite a few evaluations over the region and Africa more generally to compare these 5 different seasonal forecast models. And it turns out that the ECMWF1 generally outperforms the others, although we are working on a multi-model system where we're bringing together the best of each of those models together, depending on their skill in different times of the year and different regions as well. So in terms of the data products that come out of the system, so we have a range of hydrological variables, precipitation, runoff, evaporation, and its components, soil moisture at multiple layers, and stream flow. And you can see the attributes on the right there. So 5-kilometer gridded data for most of those hydrological variables at daily timescales, and we could possibly go to sub-daily if that made sense. And then the stream flow is on the river reach level. So that's thousands of river reaches across the country, again at daily timescale. We derive several indices from those variables. So for drought, we look at meteorological, agriculture, and hydrological type droughts. So SPI is the kind of standard index for meteorological drought. We use a standardized anomaly for soil moisture that gives us a sense of agricultural drought, and then percentiles for stream flow, which gives us a hydrological drought. And again, you can see similar kind of attributes for those indices in terms of the temporal and spatial resolution. And then for kind of flood-related work, then we look at extremes of precipitation. We also look at SPI, although this is a kind of a longer time scale index, but looking at the opposite side to drought, so looking at the longer term wet conditions. And then similarly, the soil moisture standardized anomaly, indicating wet soils, potential waterlogging, and so on. And then importantly, the stream flow percentiles. So we're looking at the extremes, the upper percentiles of the stream flow monitoring and forecasting as well in terms of flood indices. So a whole range of different types of information that's coming out of the system. We also supplement this with independent data sets from remote sensing and potentially other models as well, but we haven't included that right now in the online system, but that's future work. So just to kind of wrap up with just a bit of context about how the system could be used in terms of monitoring and early warning. So, we were kind of familiar with these kind of figures where the usual way of doing things is down the bottom of this figure, where responses are quite reactive. So it's after the disaster has happened, after the flood or drought has happened, then there's a reaction to that. So that's impact assessment, response, recovery, and so on. Whereas we like to be at the top here, where we're trying to manage that risk and be a bit more proactive. So before the disaster happens, we have plans in place to mitigate or prepare for a potential disaster. And a key part of that is that prediction and early warning. And that's where this system comes in. So it's one part of many aspects. Again, you can think a little bit more deeply about an early warning system. So it's not just about monitoring in real time and providing forecasts. It's also basing that in the context of knowledge about risk. So in terms of the system, we had our historic record that we can provide risk assessments for certain types of hazards and also exposure as well, related to floods and droughts and other kinds of extremes. Kuhn mentioned about landslides as well, so the system could be used for other types of hazard events as well. And that filters into the monitoring and early warning, giving us that context of the current and forecast conditions. And then, of course, there's the key aspects of dissemination and communication. So how can we get that information out to relevant agencies, some of whom are represented here, of course, and down to the community level, and also having that response. So, of course, we have others on the call here who are working on these kind of aspects as well. Is there the capability to actually do something different to actually respond to these to this monitoring and early warning and the alerts that go with that? So a typical application might be for flood early warning, where we have our forecast. So here showing an ensemble of forecasts that represent the uncertainty. This example here is with a lead time of 7 days. So if you have some robust information, some certainty about a flood happening, based on that ensemble of forecasts, and you have some lead time, so hopefully quite a few days to actually respond, then you can put in place a number of flood mitigation options, whether it's a flood warning, asking people to evacuate, putting up defenses, or if there are some kind of financial instruments such as flood insurance that can be put into place potentially after the flood has happened. So that flood early warning can be critical in many different ways. Another example, thinking about the kind of seasonal stream flow forecasts or forecasts of other variables, but particularly stream flow, is in reservoir management, and this could apply to water resources management more generally. So if you have a stream flow forecast here going out several months, and again, you can have this uncertainty across the ensemble of forecasts that you can assign some probabilities to certain things happening in the future in terms of the stream flow, then this can be fed into reservoir management options. This is an example from the Western US where they have quite sophisticated systems in place in terms of management, but also the use of forecasts. So thinking about the opportunities to actually feed in those streamflow forecasts into that management calendar, essentially, and to actually do something different, to make decisions on how to operate the reservoir based on those probabilistic forecasts of streamflow. Then a final example here is in agricultural decision making. Again, thinking about, say, seasonal precipitation forecasts that can be used to make decisions about, for example, when to plant and what to plant, and potentially some kind of intra-seasonal activities in terms of, say, irrigation, fertilizer application, or weeding and so on, or even bringing on and paying for labor at certain times of the year. So the examples here are just showing some work that's been done to understand the sensitivity of yields to different planting dates. So if you have information on a short-term or even a seasonal basis, you can actually use this kind of information to make some kind of informed decision about agricultural management, what to plant, when to plant as well. So that was just a quick overview of the system and what goes into it, but also a sense of the kind of things that can be done with the information that comes out of the system. Koen, if there are any questions now, happy to answer those, or we'll go to the actual tour.
Maybe just to have people getting a bit of understanding how it works, what it does, it'd be useful to do the tour first and then open for questions if everybody agrees. Unless there's any burning questions that need to be answered right now, you can always put your hand up or just unmute. But if none, I just want to give you the floor back. Before I do that, I just maybe give Gerald the opportunity to introduce himself because he was joining a bit late. Gerald, just maybe a word from you.
Thank you very much, Koen. Morning, everyone. Apologies for connecting late. My name is Gerald Mundondwa. I am here in Harare and I work for the Department of Water Resources, Utilization and Development. Thank you very much.
Thanks, Gerald. Over to you, Justin. Go ahead.
All right, thanks, Koen. So can you see the web browser with the system?
Yes, go ahead.
Okay, great. Okay, so this is the actual online interface. As you can see the web address there, so you can actually go and take a look at this. As I said, it's open. There is no registration or login. It's currently showing conditions. You can see here from the latest conditions are the 28th of March, so a couple of days ago. So as I said, we're trying to get this as close to real time as possible. Currently, we're about 2 days behind real time because of the latency of all the different data products that come into the system. And I think we can get up to about 1 day behind real time and possibly up to about 12 hours for some aspects of the system. So when you first go and open the web page, you'll see a map of what we call a soil moisture index. So that's related to agricultural drought, where you see the kind of warmer colors indicating dry conditions compared to climatology. And then the blue is wetter conditions than normal. So you can actually go through a list of variables here on the right. So I can uncheck the soil moisture index, and that will show me the next one in the list, which is SPI1. So this is the standardized precipitation index, which is mainly focused on meteorological drought. You can also look at it in terms of the opposite end, which is the very wet conditions. And this is SBI1, so it's defined on a monthly basis, and you can see the kind of range of variables, the range of values across the country right now in terms of the meteorological drought, and compare that with the soil moisture index as well. So they won't show the same thing because soil moisture is essentially a filter of the meteorological signal and relevant to different applications, of course. So just going down the list, we also have precipitation here, so showing precipitation conditions a couple of days ago, and then evapotranspiration, and finally runoff at the bottom there. So I'll just click some of these back on again. There are other ways that you can interact with the data. So you can see over on the left here is a little time series. This is actually showing the soil moisture index averaged nationally, and the little time series is quite interactive, so you can move your cursor along and actually see the values for each of those points. I can update this time series in different ways by looking at different variables. So currently you can see here national, district, and points, and I'll explain those in a second. So nationally, if that is checked and I go over to the map, then you can see that the whole nation is highlighted. And if I click on that, then it updates the time series based on which variable is shown. So currently it's showing precipitation, and the time series updates to national precipitation. So precipitation averaged over the whole country. If I go to districts, then this will bring up a map of districts. And again, you can see as I move over those, it highlights the different districts. I can click on one of those and it will update the time series to give me the current variable averaged over that district. And that works for every district that I click on. Again, I can change the variable, and that should update the time series as well, as you see over here. So this enables you to see the information spatially, but also to drill down to different parts of the country and look at the time series over the last about 15 months. Of course, we have information going back to 1979, so we have about 40 plus years worth of data, and we're working on how to actually make all of that data available through this interface. The data is certainly available through downloading just over the internet, but we're trying to make that available through this interface as well in a reasonably easy manner as well. There's also potential to animate these maps as well, so you can go back with a slider here. We'll go back a few days, and you can see it updates to, I went back to the 4th of January, then I can update this, and it will just click through the days, and you can see how things are changing. I'll just stop that there, and then I'll go back to soil moisture index. You can also see, just below the date here, you can see a few kind of statistics. So this shows the current drought area across the whole country. So it's saying about a third of the country is in drought conditions. This is based on that soil moisture index below a predefined threshold. And it's also showing that about 55 of the districts are in drought conditions as well, based on this particular chosen threshold. Obviously, these thresholds can be changed depending on the user needs and depending on the application as well. But this is just showing an example of the kind of things that we can do with the system. On the opposite end of the spectrum, we can also look at extremely wet conditions. I didn't want to call this flood because that really implies inundation. So extremely wet conditions. So this is an upper threshold on the same soil moisture index. And you can see here, this is actually much higher index than we use for drought on the opposite end of the index. It's showing that only about 1% are in extremely wet conditions and no districts overall. That means more than 50% of their area in those conditions. There's 0 districts in those conditions currently, or at least for 16th of January. So this first page gives you an overview of current conditions. It gives you time series for the various districts as well, and allows you to animate through those maps. And one bit that I didn't show is also the points as well. So these are essentially streamflow points. In the system currently, there's about 15 streamflow points that I've selected based on where observational data are available. But many more points can be added in terms of what users need, of course. I can hover over these points and see where they are. So there's information about that particular station on that river. And then if I click on that, then it will update. There we go. It will update the little time series over here to show stream flow conditions over the last 15 months for that particular point. And as I click on other points, you can see it updating as well. Again, that little graph is quite interactive, so you can see the actual values as well. There are a few other tabs here. So if I go up to short-term forecast, then I'll talk about the seasonal forecast. So if I click on that, this brings us to a tab that's all about the short-term forecasts. So the first thing you're shown is a time series or precipitation average nationally, and that's back for the last about 2 months. And then we have the forecast, the short-term forecasts beyond that. Those forecasts are shown as the ensemble mean, which is this blue line here, and also the 95th and 5th percentiles that show almost the full range of the uncertainty of those 7-day forecasts. So probably the one to focus on is the ensemble mean. That gives kind of the best representation of what we think is going to happen in the future, but it also gives the broadest range of the uncertainties as well. And we can actually refine this and actually bring this down to, say, the 33rd and the 66th percentile to give more of a likely range around the ensemble mean. Again, this is interactive, this time series. There's a little zoom bar down the bottom that you can move around and actually zoom in on various parts of the time series. So I'll show this for the seasonal forecast. That's a much longer time series, so it's quite useful for interrogating the time series in much more detail. The forecast and these time series are available for all the variables. So I can look at evapotranspiration as well. Nationally, if I update that, you can see the evapotranspiration on a daily timescale over the last few months, and then the forecast as well. You can actually download this data as well directly. So if I click on the download button, it will actually bring up a CSV file, so a text file with all the information that you see on that time series. We can also look at Streamflow. So if I click on the Streamflow, I now get a new list, which is those Streamflow points that you saw on the map previously. So I can select one of those and update the map, update the time series. Now you can see a Streamflow time series historically, and then also the forecast here. There's a bit of a gap. We're just updating the data, but imagine that these are connected. And then the background information here, the shading, is basically the climatology of Streamflow in terms of percentiles. So this gives you a sense of what the current conditions and also the forecasts are relative to what we've experienced historically in terms of this climatology. So anything in the kind of green area is kind of normal conditions. Anything in blue or above is getting into wetter than normal and maybe extreme above that line, and similarly down into the orange and red. So those colors give an indication, a quick indication of what the current conditions and forecasts look like compared to our historic climatology. We can look at summaries of the data, the forecast and the current conditions on a district basis as well. So if I click on this next tab, we have a table listing all the districts. So it's quite a long table, and various statistics. So for example, the past rainfall over the last 3 months, 90 days, the past rainfall over the last week, so 7 days, the total rainfall for the forecast, this is the ensemble mean over the next 7 days, and then some information on drought area based on the soil moisture index. So the current drought area for that particular district, and then the forecast drought area over the next 7 days as well. So we can, it's also color coded as well to actually show you the values relative to other districts, and we can sort using this table. So if we just click on one of these columns here, we can actually sort the data based on the highest amount of each statistic. So if I go to, say, current drought area, I can look at which districts are in no drought currently, and those that are completely in drought according to the threshold that I've chosen here and the soil moisture index. So it's a very interactive way of exploring the data and trying to identify quickly which areas of the country are actually in, say, drought conditions or expecting large amounts of rainfall. There's also a search box here, so I can type in a few letters and it will start filtering the list based on those letters. So I put in BU, so I now get 4 districts that contain those letters, and I can quickly see what their current and forecast conditions are. So that's based on the districts. Similarly, I can go to the river points and get similar kind of information, so organized in a table. So now I have those about 15 locations that I chose, and it shows what the current flow is in actual values, meters cubed per second, the equivalent percentile value, which gives you a sense of that value relative to the long-term climatology, the forecast flow, a maximum over the next 7 days, so kind of thinking about flood conditions, and also the equivalent percentile. And again, these can be sorted and searched by clicking on the column headings and also into the search box as well. Finally, I'll move on to the seasonal forecast. So at the moment, we only have the climate forecast, so the precipitation in there. We have the data being produced in real time for the hydrological aspects of that. So that's the stream flow, the runoff, evaporation, and soil moisture, but it's not quite into the interface yet, but that will be coming soon. So again, you see a similar kind of initial time series. So this is precipitation nationally. As this is a seasonal forecast and the time series is showing a longer perspective, so going back to the start of last year, 2020, and also the forecast here going out 6 months. So I'm just showing the forecast from January, mainly because it overlaps with the historic data, so you can see just an example of how it compares. Again, the forecast is given in terms of the ensemble mean. So for the seasonal forecast, we have 51 ensemble members that we take from the ECMWF climate model and then eventually push through our hydrological model. So again, this is for precipitation. You can see the ensemble mean of those 51 ensemble members. And then the 95th percentile down the bottom here, showing you the broadest range of the uncertainty across all those ensemble members. Again, that can be squeezed down to show, say, the middle third of the ensemble to give you a better sense of really where the forecast is going. Again, the time series is quite interactive, and we can look at different variables, so SPI, and we can look at those at national and also district scale as well. So if I just update that just to show it for a particular district. So now we're focusing on a much smaller area. Again, you can see the historic data and then the ensemble mean and the spread as well going out to 6 months into the future. Another way of looking at this is spatially. So there's another little sub-tab here called probability maps. So if I click on that and then I'll just zoom out a little bit. So what it's showing here, I'll click all these back on, is the probability of drought or flood conditions. Flood conditions really means extreme precipitation conditions relative to the long-term climatology. And we're seeing the probability of those conditions 1 month into the future, 2 months, and 3 months. That probability is calculated by the number of ensemble members out of 51 that predict drought conditions or predict flood conditions. So if we look at the drought, the probability is actually really low. So basically 0 of any drought conditions happening into the next month. Similarly for the next 2 months, as I click through these, similarly for the next 3 months. So not really drought conditions expected. When I come on to flood conditions, so these extremely wet conditions, so the opposite side of the index, we do start to see a little bit of certainty in certain areas that there might be flooded conditions, extreme wet conditions out to 2 months, and potentially some places out to 3 months. So quite a few of the ensemble members are predicting flood conditions even out to 2 or 3 months. So these probability maps give you a nice kind of spatial view of what might be happening over the next few months in terms of the probabilities. So again, useful information that could be used to act upon. And then
sorry, real quick on this interface here.
Yep.
I noticed when you had the 1 month, 2 month, and 3 month all clicked at the same time, it looked like there was practically no probability. But then but then when you turn them on, so like for the floods, like if you did the 1, 2, and 3 month floods.
So the interface is currently set up so whatever is highest up the list is shown.
Okay.
This is the 1 month. If I
Okay.
click off that, then it shows the 2 month.
Okay.
Yeah.
Yeah, because that's where I was getting a little bit confused on the interface when 3 things were clicked, but it's really only showing the 1.
Right. I have another version for another system where it's exclusive. So whatever you click, the others get turned off. Then it's a bit more intuitive then. Yeah.
Okay. Thanks.
So just the final tab here is an About tab that just shows some information about the last update, some information about the latest short-term forecast in terms of the ensemble members, its length, when it's going to be updated, or the expected next forecast update. Similarly for the seasonal forecast as well. And then there's a bit of background information and a little bit of help. Currently, it's quite limited, but we have lots of information that we can include in there. And we can also put in some contextual help on the various tabs as well. So you click on or you hover over one of the buttons and it will give you some more help information as well. So that's it. This is what the interface looks like right now. We have put in a smallest range of variables and functionality and indices, but other things could be added, of course. So this is just trying to show you a broad range of potential here. And there is huge scope to interact with people like yourselves and others to improve the system and provide more relevant information. So Koen, I'll stop there and happy to take any questions.
Thank you. I think we already had one, so as a good start. Colleagues, please, it's of course a bit overwhelming the first time you look at it. As we said, we copied the link in the chat, so you should be able to click on the link and interact yourself with the interface. As we said, it's also kind of a draft version in the sense that there may be space for changes, additions, or things that need to be updated or improved before we do a full-scale training for the colleagues in the countries, both for Zimbabwe, Mozambique, and later on for Namibia, to really get exposed to all the functionality and to work on it. So this is just for this core team to look at it, give us some feedback, ask some questions. We will also share with you a form later on that you can fill out in terms of giving your feedback so that we have your individual feedbacks as well for further processing. So it's a good moment maybe to get your early feedback, maybe also mentioning how this links with other initiatives you're aware of, you're running, so that we also know if there's any potential synergies or overlap with other initiatives on the same work. Of course, we had a meeting last year, but 12 months later, there may be things that have changed. So we want to also get a bit of an update how this all fits together as well from your end. So please, colleagues, if you want to come in, please raise your hand. You can find that on top of your system. It's a bit now put together. I think it is the third icon from the left that you can find your hand. If not, you can just unmute and ask any questions. We do value your feedback at this point. Thank you. Anyone who wants to come in? Give some reflection. Is this useful? Can it be relevant for you? How does it connect to other initiatives? Please, we want to hear from you at this point. Anyone who wants to go first? If not, before I start calling names. All right, Lena, please go.
Thanks. Yeah, thanks for the presentation. Really interesting to see progress since since the last meeting we had last year in Maputo. Really impressive work all in all. I'm asking these questions from a practitioner point of view. Red Cross, we would use such a platform and such a monitor to inform action, right? Within the Red Cross movement, we activate anticipatory action for a 5-year return period magnitude. Now, you talked about the threshold you set for the soil moisture to forecast drought conditions. Is such a threshold sort of manually adjustable depending on the end use needs. For example, for us as humanitarian actor, the 5-year magnitude that we trigger against or for. That would be one question. Another question, also again from our perspective, what is interesting for us to inform decision making on where to direct interventions is the vulnerability layer. So in addition to your forecasts and the monitoring that you provide on this platform, we would need to join in a layer of vulnerability based on vulnerability indicators that allows us to understand in a region, for example, forecasted to be affected by drought, these are the most vulnerable districts. So question here, if that would be on the longer term a possibility to add a vulnerability layer to be able to better predict impact, humanitarian impact, for example. And last question, is there also a plan to possibly link concrete alerts to the forecasts, and that again from a practitioner point of view of being very valuable of such a monitor also issuing alerts possibly automatically to practitioners to be informed by it. Over to you.
Thanks for that. I'll just give the floor to Justin first, and I will then make also some comments on some of these issues. Justin?
Yeah, thanks. Great questions. By coincidence, our threshold is actually the 5-year return as well, so it's already in there for you. But what we could do is actually be quite straightforward to actually make allow the user to actually define their own thresholds. So they could actually change it in terms of, say, the return period, the percentile, or some potentially an absolute magnitude as well, though that might be a little bit more difficult. So the user could actually define that threshold, and then all the maps and the time series will be updated. So the good thing about the approach that we've used with the underlying software is that it is quite dynamic and actually update those calculations in real time. So there's potential to actually make that part of the user interface, so the user can actually select those thresholds. In terms of the vulnerability layers, yeah, it's very easy to add other layers to the system. So currently we're just showing the hydrometeorological information, but any kinds of GIS, spatial layers or even time series could be added to that as well. At University of Southampton, we actually work closely with the World Pop Center, which is part of our school. And I don't know if you've seen their work, but they produce a lot of kind of vulnerability associated or relevant kind of layers in terms of, say, population and poverty maps as well. And we're actually working with them to try to integrate some of that kind of information in the system. But if you have particular layers that you already use, then it'd be quite easy to add those if they're just a kind of a spatial layer. And then finally, the question about planning to link to alerts. Yeah, there's lots of potential to do that. We do know how to try to get this information via SMS messages and so on. Obviously, we can send out things via email. There are other ways to package up this information in reports that can be sent out more manually. So there are lots of different ways that we can do that, but we haven't implemented any of those yet because we would like to talk to people like yourselves about the best way of doing that. And I think, Koen, you have some ideas about how to do that, particularly for this region, don't you?
Right, so there's a few things I want to add there. So Lena, indeed, we have also been in discussions on the Zimbabwean side of things with the Danish Red Cross, and we're actually just launched a project together for a small area of Zimbabwe, which is on the border with Mozambique. It's in Chipinge and Chimanimani. So basically in the Bupusa area, the Busipungwe, more the Save and the Buzi actually. So that will also allow us to work together with Red Cross Zimbabwe, Red Cross, the Danish Red Cross, to look into early action protocols, specifically for floods. So they have been working a lot on droughts, but not necessarily in that area. So we decided to team up and to find a way to bring this kind of information more into the operational space. It's not our mandate, but it's of course your mandate as well as some others to do that. So I think it's important we team up and we find a way that this information can reach that objective. In terms of vulnerability, indeed, yeah, that's also exactly the point. They were also highlighting some of the tools they have for vulnerability assessment using the Red Cross volunteers that have been trained to do some assessments like that. So we're looking into that for the Zimbabwe side, and it could also be interesting to look into how we connect there for the Mozambican side. On the alerts, I think that's also kind of connected to that. Maybe just one mention, the Red Cross works, of course, with 510 to do these localized vulnerability mappings. And we're also looking into how we could bring that in at some point, or vice versa, that they bring in this information in their entry. So there is certainly opportunity for working together to make it more impactful forecasting. In terms of alerts, you're right also that is an opportunity to look into how we can bring those alerts into action. For the same project in Zimbabwe, we will be setting up, for example, community radios into districts, and that will also be a pathway for further dissemination of this kind of alerts. You know, they will be trained, and they will be also training community members on the same. So that's also an opportunity. Now for Mozambique, we were approached also by a donor to come up with a full proposal on strengthening the flood early warning for specifically Bupusa, not only for Zimbabwe, but also for Mozambique. But of course, the Mozambican side is much bigger. So the biggest part of the project would be for Mozambique. This is a quite new development, and we think that this system, which is kind of the baseline for that work, could be a useful starting point, but not necessarily the final way of using that information. I hope that answers some of your questions.
Yeah, great. Thank you.
I see also Elisha is there. Elisha, please comment.
Hello. Yeah, thank you, Kun. There are some real-time stations in both Mozambique and Zimbabwe. Very few, of course, at the moment. I know in the Pungwe and some in the Buzi. I think the model can even perform better if there is a linkage between those hydrological stations which are monitoring on real time to this model, so that you continuously correct the figures as you go, the flow figures. Thank you.
Justin, you want to comment on that?
Yeah, that would be. Yeah, I mean, that would be really useful. We currently take most of our station data from global databases and some regional ones that are, relatively up to date. The full amount of station data doesn't come into about 1 month behind real time, but certain subsets of information does come available nearer real time. So anything that is available in the country that's real time would be fantastic. And we can easily assimilate that data into the precipitation data, or potentially even into the streamflow modeling as well, to correct the model and get it closer to what is happening actually on the ground. Yeah, so that would be great if that could happen. Yeah.
Yeah, thanks for that. I think that's indeed a discussion we should have as well, because for the Zimbabwean side, this meeting, which was held 2 weeks ago on the same, was also sparking, let's say, a further data collection to improve the system further. So we received from the Met Office, MSD, as well as from Zinwa, more detailed daily station data for several locations in the country to do the better calibration and validation. So I think that's also a discussion we want to have with you, that this discussion should also move in that direction, that we can identify potential stations that can be shared, but also, as you say, look into potential real-time stations that are available. We asked PCI to do that work, but it's only, of course, doable when we actually have that data. So I think the first step is to identify which stations are available in the area that could be available for them to ingest continuously. Because of course, if you want to have real-time stations involved, it means they should be up as much as time as possible, so they become a relevant entry source for data. So that is a good discussion to have, Elisha, maybe also for the Bupusa area binationally, to see if that information can flow freely to make it available. Maybe Ilario, I would just ask you directly, since you're representing the the water department. I know there is quite a lot of hydrological data available from the country, and my understanding is it's available upon request. I know for the met stations that's a bit of a different story, but from the water, I understood that that data might be available for example, calibration, even if it's historical data with maybe only a few years available. Could you give us maybe an update on effectively if that data would be potentially available for improving the system further?
Yes, thank you. Yes, let me first congratulate the UNESCO in this presentation. This is a good tool to monitor the drought and the floods in the Bupusa area. I will apologize in terms of the participation of my colleagues in this meeting. In my daily routine, the issues of the hydrological data and the models is a part of other colleagues that most of them is not here, but I have another colleague that deals with the databases, hydrological data. Maybe my colleague can assist me in terms of the models that we are using, the many stations that we are monitor, and the issues of the useful of this platform, this model, taking in account that we have other models that we are using. So I will call my colleague, Mr. Malanso, is here in this meeting, and he deals with this kind of issues daily. Maybe they can assist us. He come late to this meeting because we have other meeting that is running right now. So, Mr. Malanso, can you assist me on this?
Yeah, okay. What I can say, yeah, I was not. I didn't see all the presentation, but this is not my first time to see the presentation. I was involved when the project was presented in Maputo, and also I know that the UNESCO requested the National Directorate for Water Resource to provide the data. What I know that the data was given to UNESCO. So what I want to say is, like, we have been collaborating in this process of giving historical data, or even the more updated data. But if there need of data, if you still need data, additional data, I think we are available to provide that. As Mr. Madamombe said, we have now new stations, that telemetric station. You can go through the system and you can go through website and see the data. But we are in the process of transferring the server of this station from the provider to our database. But the data is the data is available. If you want, we can provide you. And from National Directorate for Water Resource, data are given freely. We don't charge for providing information on data. Even through DNGH or through R Central, they're managing we have the regional authority who is managing the Boost Basin. They have also data if but what they have is the same that we have here. So if you want data, additional data, you probably can identify which station you want, and we can provide you with the additional data. This is what I have to say now, because as I said initially, we have been, I was involved in this project for some time. My colleagues from the department, they have been also assisting some presentations, so we are aware of the project. Thank you.
Thank you very much. And I think that's very useful. And I need, we had some back and forth on the data. I think we don't have received actually the data itself, so we may have to have a look at that. But I think, it's very, let's say, positive that we can collaborate further on this. As I said, also, we also need to have further discussions on the proposal that we want to submit to the donor for the full project. So I think there's also an opportunity for the colleagues here to discuss further on and see if we can send something that will really be impactful on the ground. So that's something I would like to invite you for a follow-up meeting, probably in a week or so from now. And that can also help us further on the discussions. I'm also seeing if the colleague from the Met agency, I think we have a similar question. I think we had discussions with Aderito as well on this. So I think he's also eager and supportive of the project. So I think it's also a question of coordination with the Met office to coordinate some further input. Of course, the data will be as good as the data we have for calibration and validation. So the better effort we do in making sure that the data is, let's say, validated and calibrated, it means the system will operate better and more useful for action. So in this sense, we also look forward to finalize that work with you all. Colleague from the Met Service, Nantumbo, I'm not sure if you want to comment on that.
Oh, sorry, come again. Is the comment in regard to data sharing or the presentation?
Yeah, I was saying indeed, if we can indeed further collaborate with the Met Office just to make sure that we can use some of the data to calibrate the system further so that it operates as good as possible.
Yes, I don't have much to say in terms of data because I'm in the Department of Planning and Research, and there are some politics when it comes to data. So,
okay.
Yeah,
no, we can follow up on that.
Yeah, I know that the data is made available through some payments. And depending on the situation, it can be provided freely. But the terms of it, I'm not full aware.
That is fine. I think we can then follow up later with the director and see how we come to an agreement on that one. That's fine.
Okay. Thank you.
Okay. Do I have any more questions on this? As I said, the following step from our side is to ensure we follow up individually. We'll probably share also a form for your feedback to be received so that we have a clear understanding if you have any comments or issues we should look at which have not been discussed today, so that we can also make sure that by the end of May, when we have a training with a more broader stakeholder group, that those issues that can be addressed in the inter period can be addressed. So anyone wants to come in additionally? The objective of this meeting was to be informative, so if you have any questions or issues you would like to raise, now is a good time. I don't see any further hands. Okay, Malenko?
Yeah, I didn't get very well what the next steps.
Okay, so
This process, yeah, because I know that you have been doing this for almost a year ago. So what's the next step? And when the country will be able to use the system?
right. So I think that's a good question. I think we had a bit of a delay, and I would apologize for that. So last year we launched a version which we could not continue using, and that was one of the reasons why we come back to you with an updated system. Because at the time we were using it last year, it was not sustainable over the long term, and we decided to move away from the approach that was taken that time, and to move towards more of an open access, open source system, which then needed to be rebuilt. So the reason you're looking at a slightly different version of what you saw last year is because it is being completely overdone. Not so much on the modeling side, but much more on the front end, the access of it. So we feel that's a big improvement over the last system, which had some issues to it. So that's one step. Now the second step is that we were sourcing individual resources from different interested contributors or donors to support the system further, because we know that just having an online platform is not going to be enough to make a big difference on the ground. So we also have been putting forward this concept note where we would like to work more on a community-focused or community-based early warning system. So that means that also communication should be there. We need to talk about also early action protocols, risk assessment. So a lot more elements to it that where this system is embedded and can be further expanded. So in this sense, this is a first step for us to be back at square zero where we were last year, but in a much better format, which can be also be used for further capacity building and also be built upon by partners who have capacity to work on on open source tools such as universities. So I think that's where we are. What is the next step? The next step of this process ends in May, where the final version will be released publicly. So we would like to invite through your networks to invite people to be exposed to the system and have kind of a final validation workshop on this system, which is not the end of the whole process, because we want to go beyond that. As I mentioned, we would like to see if we could also engage on the communication side of things, on the vulnerability assessment side of things. So we would like to engage with you all to come up with a more performant project that could take this step and turn it into an operational system for particularly Buzi, Pungwe and Save, transboundary watershed, but of course also looking at the option to upscale that effort to the larger country level. So that's a conversation we are just starting. We do get confirmation that the donor is really interested to support it, but we need to come up with a performant project that also gets the necessary buy-in from the different entities in the country. So that's a requirement that we need to fulfill. And if we feel that it's possible, then I think we can go for a more significant implementation at a very local level, even the community level. I'm not sure if that answers your question.
Okay, it's clear. Okay, I understood.
Okay, so we do welcome, and we'll also have our colleague here on board, Augusto Nunes, who is our focal point in the government from the UNESCO National Commission that helps us also with the communication with you and setting up meetings and ensuring that we have a good communication with the different ministries and entities that are relevant in this sense. So we will be requesting for follow-up meetings individually to make sure that the proposal we are sending to the donor is aligned with the objectives of the individual partners. And for example, predominantly the weather agency, the water agency, the disaster risk reduction agency, but also, of course, other partners such as the Bupusa, Red Cross, and others. So in this sense, you can expect some further discussions. And I do have some emails from you. I don't have your email, Malenko, so if you can just drop it in the chat box, then we will also reach out to you, making sure you're part of those discussions.
Okay, thank you. I'll send my email. No problem.
Thank you very much. All right.
Yeah.
So, any more comments on this or other aspects? We also make sure we have the recording ready for you to follow up. And I see the hands up from Mr. Nantumbo and then Chris. Please, Mr. Nantumbo.
Yes, thank you. We do have some initiatives with the WFP in drought forecast and monitoring. And I know also another initiative that I'm not fully aware at which stage we are with the Mozambique Red Cross. But in those initiatives, there's this aspect of technical capacity building. Are you considering this aspect in this project?
Yes, that's certainly one of the components that need to be addressed, and we will also foresee a big component for capacity building. So it's important also for them, and the donors also highlighted that the capacity building should go beyond the national level. So we have to have the national level, which is you and your core members, but also we want to look into provincial and even maybe district level capacity building for these additional tools, and also making sure the tools are tailored for their use. So there must be really go beyond just the introductory information, but really go to capacity building so that these tools can be eventually transferred to you and to the ones that should be dealing with this at the long term. So we want to make sure that that transfer and capacity building is a core area of that work. So I'm not sure if that answers the question.
Yes, sir. Thank you. So another aspect has to do with the resolution of your output. So are you thinking to go beyond the district level? I mean, like a municipality to bring more high resolution results?
Good question, and maybe also a colleague Justin can respond to that. But in fact, we can go much more high resolution. Of course, then the data inputs become more important. So as long as we don't have better inputs, our resolution is not necessarily better, even if we go for a model that can show higher resolution. In principle, there is an opportunity to go to the 30-meter level of visualization, but only if indeed the data that sustains that level is available. So maybe Justin, you can give a short comment on that as well.
Yeah, thank you. I'll leave to Adam.
Yeah, just to add that the current system is running at a 5-kilometer regular grid over the whole country, and we have the very high resolution river network as well. The information that you see on the interface can be shown at the district level, but the underlying information is higher resolution than that. As I said, 5-kilometer, and then these thousands of river reaches. And as Koen mentioned, we have some experimental work with another hydrological model that allows us to get down to the field scale, so essentially the tens of meter scale. That's also commensurate with a lot of satellite information at that kind of scale, 30 meter, 20 meter, and so on. So it is possible to implement a version of this system at the very high resolution, and then that gets down to things like being able to identify landslide hazards at the real scale of those kind of processes, for example, as well as many other applications in, say, agriculture and also flooding as well. So we're going to try to experiment with some of those systems, and it may be possible that we could try to test some of those out for Mozambique at some point in the future.
All right, thanks for that. I also see Chris's hand up.
Yeah, thanks. This is just a quick question. For your feedback sessions, I'm wondering what kinds of feedback would be possible, like would be actionable, because for example, there are some elements on that district list where maybe if there was province and district, that could be helpful, or a dashboard which says these are the 5 most at-risk districts or something, or a different kind of graph and chart, which could be interesting for end users. But I'm not sure if that kind of thing is possible to change, and if that's the kind of feedback you're looking for.
Yeah, my answer would be yes. That's exactly the feedback we're looking for. Indeed, if there is a clear need for a specific type of visualization or information that is not there, then that's effectively what we were looking for. And I don't think there's any problem to adjust anything since it's quite moldable to any needs. Of course, it may take time if it's a significant change, but I think in principle, that is kind of the things we're looking for, right, Justin?
Yeah, that's exactly the kind of things that would make it more usable, as well as any feedback on the actual, the values. So a little bit of validation would be really useful as well as additional functionality. The most important thing for us would be to try to gather feedback on functionality that is somewhat generic, so we can apply it to other systems at the same time. So if it was a very specific focus thing and it was a one-off, then it's possible to do that. But if it was many specific focus things, then it would be a little bit more challenging. So things that are a little bit more generic, and some of those things that you mentioned would be possible because we could apply those to other systems at the same time and be much more efficient then. So yeah, please, any feedback. No guarantee that we can do everything.
Yeah, so one suggestion on that feedback might be to segment out some of your different user profiles. So like the administrators versus decision makers versus the humanitarian folks, and maybe get those as different groups and then walk them through and just sort of see what they sort of bump on or react to or ask for. Because different users are going to be using the system for very different purposes, even though it's all the same information.
Yeah,
right.
That's a good point. Yeah.
Yeah, so also we have a bit of a diverse group here as well, and we hope indeed that we will get different feedbacks. And as I said, we will open up for larger consultations in the more full training that also will give us some additional feedback. So we'll be having such certain iterations on that as well. So I think that is part of the process indeed. Colleagues, I have some other hands up, but I think they're from before. Unless you want to come in on another issue, I think we can almost close the meeting. Anyone who wants to come in for final comments or questions before we do that? As I said, we will also make this available as a recorded video so people can actually look at it at a later stage, or you can share it with colleagues so that it can also be used for further feedback from them if they would be interested. Any more comments? Once, twice, 3 times. I see none. So colleagues, I would like to thank you for taking your time to be part of this short demonstration and information meeting. I will look forward to working with you much more intensively in the next few weeks to really come up with a concrete proposal for further work. We already have a concept note developed, but we want to really make it more rich and connected to maybe more updated information that came available in the last 12 months. Since we had no opportunity to travel to Mozambique over the last year, we're a bit outdated in terms of what has happened since then. So we'd like to really reconnect with you and make sure we have a good dialogue that can lead into an implementation of this additional project that we hope would really bring benefit to the communities in the Bupusa area for Mozambique. So with that, I would just also want to thank Justin for his presentation. We'll make it available to you so that also if you want to have a quick look at it, please feel free. And if you have any questions or you want to reach out to us, of course, please do. We're here to support that as well. So thanks for that. So with those words, I would then maybe call the meeting to an end and look forward to engaging with you further in the next few weeks and months. Thank you very much.
Thank you, Koen. Thanks all.
Thank you. Thank you. Bye.
Thank you all.